Hello, Luke. Welcome to Lesson 30. So today we're going to be talking about algebraic phrases and decimal parts of a number. All right. Let's start by talking about algebraic phrases. I've got a bunch of them listed to the left of the page here. And when we talk about algebraic phrases, all we're really doing is recognizing the fact that mathematics is a language. It's a language of symbols. And we can use those symbols and manipulate those symbols to arrive at solutions to problems. Okay, so one of the things that we really have to become proficient at in algebra is being able to translate the English language into the mathematical language. All right, that's very important. Otherwise, we might have a real world problem. And if we can't translate that into a mathematical equation, then there's really nothing we can do to solve that problem mathematically. So it does become very important to be able to translate things from the English language into kind of the algebraic language. All right. So with that being said, we're going to go through some of these. These are going to become very important when we start talking about word problems. And we won't be actually doing word problems today, per se, but we will be doing them in the future. So it's very important that we get good at translating these phrases into algebraic expressions. All right. So let's take it one at a time here. And as we go through, we'll kind of pick out some English words that we need to be able to know what the mathematical translation of that English word is, and we'll kind of compile a little bit of a list that you can then memorize so that you can become very proficient at this. All right. So let's take the first phrase here. The sum of a number and 4. Okay. Now, I find the easiest way to do these is simply to read the whole thing, try to kind of get an understanding as to what is being said in this phrase, but then start from the beginning and just slowly work your way through the phrase, translating as you go. So if we start from the beginning, we notice that the very first part of this says the sum of. Okay, so I think let's have a little bit of a list that we'll start compiling over here, and maybe we'll do that in red. So the sum of. So whenever you see the words sum of, okay, these can be translated to an addition problem. Okay, so this is telling us that something is being added. There is an addition problem going on here. Okay, because bear in mind what the sum means. Remember, going way back, if I have 3 plus 4, if you recall, this top number is called the addend, the next number is called another addend, and then the solution to this problem, the answer to the problem, is called the sum. All right, so when we talk about the sum of something, we need to recognize that, okay, we're talking about two things being added together. All right, that's what we need to recognize. So as we go through this word expression, we will start by saying the sum of. Well, let's just stop there and say, okay, I know what that means. That means addition. I'm just going to put an addition sign. We know that two things are being added. There's something over here and there's something over here, and they're being added together. Okay, so we have the sum of a number and 4. So what that's doing is it's telling us what those two addends are. Okay, it's a number and 4. Now, we don't know what the number is. They didn't tell us what the number is, but it's some number and 4. So you may remember back to some of our other problems where we had what fraction and what number, and we just called them a WN and a WF. Kind of the same thing applies here. We're just going to use a capital N to represent number. So we have the sum of a number, and we'll just call that an N. All right, an N and 4. So this is what that English phrase could be written as algebraically. We're translating this English phrase into this algebra phrase. We have the sum of a number and 4. That's exactly what this is saying. N plus 4. That is the sum of a number and 4. All right? Do you see how we translated that into an algebraic expression? And at this point, we could then, potentially try to solve this expression. Now, in this case, we don't quite have enough information to be able to solve it, but we certainly have the beginnings. We have a number plus 4, the sum of a number plus 4. Okay? So hopefully that kind of makes sense. One thing I might point out here is just to, and I'll say this just to avoid confusion later on, notice we have the sum of, and you might recall in a previous lesson, we talked about if I have something that says, half of 4, the of always means multiplication, right? 1/2 times 4 is 2, right? Well, in this case, know that the sum, the word sum, if that of is being preceded by the word sum, then that sum of actually means addition in this case. So watch out. Don't just go, oh, I see of, that must mean multiplication. No, not in this case, because it's preceded by the word sum, and we take that sum of as one whole clue word, sum of, indicating an addition problem. All right, so watch out for that. If there's the sum, it doesn't mean multiplication, it means addition. Okay? All right, let's go on to the next one. So the next one we have 4 less than a number. All right, well, we have the number 4 in the beginning. That's easy. We know how to write the number 4. So obviously we're talking about a 4. And what's happening to this 4? It's 4 less than a number. Okay, less than a number. Okay, so this less than, we need to determine what that less than means. So that would be another clue word for us over here. Less than means to subtract. Okay, and that may be obvious. The thing to avoid here is the issue of deciding what gets subtracted from what. So 4 less than a number. You might be tempted to say, okay, 4 less than, well, that means subtract. And then a number. Well, we don't know what that is, so we'll just call it an n. So there we go. It's 4 minus n. And actually, no, that's not true. So this one you got to watch out for. Think about this for a second. 4 less than a number. 4 less than a number. So what we're saying is we have a number, and then we're taking 4 less than that number. Okay, so 4 less than that number actually indicates n minus 4, right? We have a number, and then we're having 4 less than a number. So we're taking away 4 from that number, okay? We're not saying we have 4, and then we have n less than 4. Okay, we're not saying that. We're taking the 4 away from the number. We're not taking the number away from the 4. Okay, it's 4 less than. So when you see that less than and it's preceded by a number, know that that 4 less than indicates that we're subtracting the 4. All right, so this is not correct. It's actually this one over here. It's n minus 4. 4 less than a number. So you see the 4, you can write that down, but then when you see that less than, just know that, okay, whoa, we got to back up. We're not actually saying that it's 4 minus something. We're saying it's something minus 4. Okay, so the 4 actually comes at the end of the expression, even though it came at the beginning of the expression over here. All right, so watch out for that, because that's a very common mistake that people make. They want to write it like this one, 4 minus n, and that's not correct. It's 4 less than the number, n minus 4. Okay? Okay, very good. So let's go on to our next one here. The opposite of a number decreased by 5. The opposite of a number decreased by 5. So we need to talk about what the opposite means. And we've done this before. Remember in the very beginning when we talked about negatives, we said another way to think of them is by thinking of them as opposites. So the opposite indicates you might say the negative of the number. Okay, the opposite indicates the negative of the number. So if I were to say, what is the opposite of a 4, you would say, oh, it's the negative of that number. It's a negative 4. That's what the opposite would mean. If I said, what's the opposite of a negative 4, you would say, oh, it's the negative of that negative 4. So it's a negative of the negative 4, which is, in fact, a positive 4. So the opposite of a negative 4 is a positive 4. Right? So the opposite would indicate that we're essentially just putting a negative sign in front of whatever that number is. If it's a positive number, well, great, then we're going to end up with a negative number. If it's a negative number, we actually end up with a positive number because we double up on the negatives, negative, negative, which would then give us a positive, right? So the opposite would indicate the negative of the number, okay? So getting back to our problem, the opposite of a number decreased by 5. Now, I don't really care about this decreased by 5 yet. Let's take the first part of this. The opposite of a number. What is that? Well, again, we don't know what the number is, so we're going to call that n. But we do know that we're taking the opposite of that number. So it's going to be a negative n, right? Now that we have that, we can continue with the rest of the problem. Decreased by 5. So what's happening to this number? It's being decreased by 5. All right. So that means it's getting smaller. We're minusing. We're subtracting. We minus the 5. It goes down 5. It's decreasing by 5. So we subtract 5 from that. All right. So let's put out another clue word. So the other clue word might be decreased by. And decreased by just indicates that we are going to subtract. It's another subtraction clue. Okay, so less than means subtract. Decreased by also means subtract. Okay. All right. Now, let's move on to the next one. So we have the sum of the opposite of a number and negative 5. So here we have, again, the sum of, which we already said earlier, indicates addition. All right, so we know that in this particular expression, we're going to have an addition. Okay, so what are we adding? Well, the sum of the opposite of a number and negative 5. So you might first try to figure out, okay, what's being added here? What are the two add-ins for this expression? And it's the sum of something and something, all right? Well, the first something is going to be this, the sum of the opposite of a number and negative 5. So these are our two add-ins. This set of parentheses is being added to this set of parentheses. The sum of this and this. All right, if it helps, don't even read all this. Just know that it's something. The sum of this and this. All right, so now let's take that first set of parentheses, this one right here, and now let's look inside and try to discern what this translation would be. So the opposite of a number. Well, we've already talked about that. We don't know what the number is, so we call it n, and then we know that it's the opposite of that, so we have the opposite of n. Okay, that's that first set of parentheses, which we said was the first add-in to the sum problem. So that goes here. Okay, now we have the second set of parentheses, and this one there's nothing really to decide. They've really given it to us. It's a negative 5. So this one is going to be a negative 5. So we could kind of simplify this expression a little bit by saying that this is equal to negative n. Now, a plus minus 5, that is just minus 5, right? The plus and minus, the negative is going to win, and we're going to end up with a negative 5. So we could write that as negative n minus 5. That is the translation of this English expression into an algebraic expression. All right? So again, the key on this one is recognizing that we have the sum of something, and you need to first figure out what part of this expression is the first addend and what part of this expression is the second addend for that sum. Okay? All right. Let's go on to the next one here. The product of twice a number and negative 5. Well, first let's talk about product. That's another clue word. So product, would indicate multiplication, right? For the same reason that sum of indicates addition, okay? So in multiplication, if I have 3 times 4, you might remember that some books will call this top number a factor. Other books may have called it a multiplicand. The second one they called a factor, or some books called it the multiplier. Just depends on what book you used. But perhaps, and maybe in this case it makes more sense in algebra to call the first one a factor and the second one a factor. And then the answer, we called that a product. Hopefully this is ringing some bells. So the product is the answer to a multiplication problem. So when we see the word product, we know that we're talking about a multiplication problem. Maybe I'll put that multiplication problem. Okay, so the product indicates multiplication. So we're going to throw that down, multiplication. Now we need to figure out, okay, what's the first factor and the second factor? Well, we're going to kind of do what we did before. The product of, and again, this is, I should probably point out, this is just like the sum of. There is that of there. And I suppose it's almost redundant in this case. Of, I said earlier, meant multiplication when it was by itself. It also means multiplication when it's used with product. So product of means multiplication. All right. So the product of twice a number. What's the first factor? Well, it's this and something else. So it's going to be this, and then here's our and this. Those are the two factors, this and this. All right, so what is the first one? Well, the first one is twice a number, twice a number. So if we think about twice a number, what is that indicating? Well, that means we have a number, we don't know what it is, and then we're taking twice of it. So we're going to be multiplying it by 2. We're doubling it. Twice a number. 2n. You follow me? 2n. And then our second factor is very simple. It's just the negative 5. And I'm going to put that in parentheses, actually, since I have multiplication here. Okay? So the answer is 2n times a negative 5. And I'll just make that multiplication invisible. 2n times a negative 5. All right. This could even be simplified. We could then simplify this to 2 times the negative 5. This is all multiplication. There's no addition going on here. So I can multiply my coefficient terms here. 2 times a negative 5. Well, that's a negative 10. So that's a negative 10n. All right. So here we were actually able to even compute this a little bit more. Okay, you might say that, excuse me, you might say that this is the true translation for this expression, but this is kind of the simplification of that expression, of that translation. All right. Excellent. So really, I would actually, at this point anyway, I would probably accept either one of these answers on your homework. It kind of makes more sense to just multiply that through, though, and simplify it. All right? Okay, so the next one. The sum of twice a number and negative 5. So here again we have sum of, we've talked about that before, that would indicate addition, right? Right away we know there's addition. All right, so we need to figure out what are the two add-ins. Well, we look for that and. That's kind of a key part there. That kind of separates the two add-ins. So the sum of what and what? Well, the sum of twice a number and negative 5. Those are my two add-ins. So my first add-in is twice a number, which we just talked about. Twice a number is a 2n, and a negative 5. So we're adding a negative 5. Now, in this case, we could simplify that out to be 2n minus 5, right? The plus minus, the minus wins, 2n minus 5. All right, let's go to the next one. 5 times the sum of twice a number and negative 5. Bah, that's a mouthful. All right, let's break it down. So we have 5 times. All right, well, let's see here. Let's put another clue word over here. So times indicates what? You got it. Multiplication. All right, so times indicates multiplication. So 5 times the sum. Whoa. All right, we're talking about 5 times the sum. Let's think about that. It's 5 times a sum. A sum. All right, so what does that mean? Well, we're multiplying this 5 by an addition problem. Remember, sum. It means addition. Sum of, addition problem. So 5 times the sum of. Well, it's 5 times an addition problem. So if it's multiplied by an addition problem, I'm actually going to put that addition problem in parentheses because this 5 is being multiplied by that whole addition problem. It's not just multiplied by the first addend. It's being multiplied by that whole addition problem. So we're going to include that in parentheses to show that this whole addition problem stays together and that whole thing is being multiplied by the 5. All right. So inside here, we have an addition problem. So it's 5 times some addition problem. All right. So 5 times the sum of, now we have to figure out our addition problem. The sum of what and what? Well, it's going to be the sum of twice a number and a negative 5. That's what the sum is. So twice a number is our first addend. So twice a number is going to be 2n. And then 5, negative 5. They give us that, so it's a negative 5. Now I could simplify this a little bit more and show that this is equal to 5 times 2n minus 5, right? And if I really wanted to, I could even simplify this more by distributing through the 5. I could take 5 times the 2n and then plus 5 times the negative 5 times the negative 5. I certainly could do that. That would be just simplifying this more. A little bit similar to what we just did up here. I think in this case, though, this makes it a little bit more clear that this is the translation. I think I'll just keep it at this. That is the strict translation for this. And then we could certainly go ahead and kind of simplify this down a little bit more. Okay? Excellent. All right, so this next one, I want you to go ahead and try this one on your own first. Pause the video, give it a try, and then we'll do it together and see how you did. All right, so we're talking about 6 times the sum of twice the opposite of a number and negative 8. Wow. All right, that is a mouthful. So let's break that down. 6 times. Well, we've already talked about times and what that means. So it's going to have multiplication, and one of the factors of that is going to be a 6. It's 6 times something. All right. So 6 times the sum. Okay, here we go. The sum of. So it's very similar to the last problem. We're multiplying this by a sum of something. Now remember, we want to set that in parentheses because this 6 is being multiplied by the whole sum. Not just one part of it. It's being multiplied by the whole sum. So we'll put it in parentheses. So it's 6 times the sum of. And what's the sum of? Well, it's twice the opposite of a number, and negative 8. Those would be the two parts of that sum. Twice the opposite of a number and negative 8. All right? So let's figure out this first parenthesis here. Twice the opposite of a number. Well, twice indicates 2 times something. Twice the opposite, well, that indicates we throw a negative sign in front of it. And now we have a number. So it's a negative sign in front of a number, and then it's twice the negative sign, or twice the number. All right? So it's going to be a negative 2n, right? Do you see that? This would be twice the number, and it's also the opposite of a number. So it's twice the opposite of a number, negative 2n. All right? And negative 8. So this becomes a negative 8 over here as our second addend. And then, of course, we can just kind of simplify this out so we don't have these two operating signs right in front of each other here, this plus minus. So this is going to become 6 times a negative 2n minus 8. All right, and again, we could simplify this further, but we're going to leave it at that. All right, so hopefully you see how that works. Let's go to the next one. The product of 7 and the sum of a number and 10. Go ahead and try this one on your own, and then we'll do it together. All right, so the product of 7 and the sum of a number and 10. All right. Well, we're talking about the product again. I'll go to a different color here. Oh, let's see. We haven't done a purple for a while. Let's do purple. So the product of 7 and the sum of a number and 10. So product means multiplication, right? Product. 7. What are we multiplying here? The product of 7. So that's one factor. And there's our and. Remember, the and is what separates these two numbers from each other, the two factors, or the two add-ins if it's addition. So 7 and, so we know one side is 7, and the sum of a number and 10. So the second part of this factor, or this product, the second factor, is the sum of a number and negative 10. So the second factor is another expression. So we're going to set it in parentheses. The second factor is the sum of a number and 10. All right, well, then we have the sum of. That indicates addition. So it's an addition problem here. Sum of what? Sum of a number. Well, we're going to put an N for that. And 10. Put a 10 for the other one. So we have 7 times the sum of a number and 10. So this would be our algebraic translation of this English problem expression. All right? Excellent. All right, let's go on to the next one here. Give us a little bit of room. Go ahead and do this one by yourself, and then we'll do it together. All right, so here we have the sum of again. So again, we're talking addition. Okay, sum of what? Well, let's look for that and. Here's the and. So sum of 3 times a number and negative 4. Now, notice the comma. This one's so important. I'm going to try not to cover that comma. That comma tells us we need to stop, almost as if that were the end of the problem. All right? It's almost a problem within a problem. So we see that comma, we need to stop and just look at where we are at that point before we go on to the next section. So the sum of what? The sum of 3 times a number. 3 times a number would be 3n. And a negative 4. So the other addend here is a negative 4. The sum of 3 times a number and negative 4. Okay? Now that could be written as 3n minus 4. Right? Okay, so now we're done up to the comma. Now we can look at what happens after the comma. So the sum of 3 times a number and 4, comma, multiplied by 5. So that would mean, because of this comma, everything that we've done up to this point, we are now multiplying it by a 5. Okay, so we need to take everything. And by everything, we're going to just set everything in parentheses. Just lock all that together in a set of parentheses. And then we're going to multiply that by a 5. And sometimes it's a little more conventional to write that 5 out in front. So we have 5 times a 3n minus 4. Okay? Do you see that? 5 times 3n minus 4. We're taking that whole first part of the problem and multiplying it by 5. That comma is what tells you that. If I didn't have that comma, it would also be an interesting problem. It would be the sum of 3 times a number and 4 multiplied by 5. So if I didn't have that comma, this and, we'll choose a different color here. We would have said the sum, so we would have put addition, right? And we would have said what would be the two parts? Well, the first part is 3 times a number, because that's where we hit that and. But then if this comma was not here, we would have included all of this as the second sum, or the second addend, and negative 4 multiplied by 5. Okay? Do you see the difference? Because then we would have said the sum, we have the sum. The first addend is 3 times a number, it's 3n. The second addend is negative 4 multiplied by 5. So the second addend would be, negative 4 multiplied by 5, which is a negative 20. All right? And we would have ended up with 3n minus 20. And you can see how this is not the same as this. They're very different. And the reason they're different is because of this comma. This comma tells us to stop what we're doing, do everything first, come back and look at what's after that comma, because what's after that comma is actually being applied to everything in the first part of the problem. So commas are very, very, very important. Okay. All right. Let's look at the next one here. So go ahead and try this one by yourself, and then we'll do it together. All right. So the sum of -10 and 6 times the opposite of a number. So once again, we have sum of, so that indicates addition. What are we adding? Well, -10, and then we hit this and, so we stop. So we have a -10 on one side and 6 times the opposite of a number on the other side. All right, so we have a -10 on the one, and then 6 times the opposite of a negative number. So if you wanted to write that out literally, it'd be 6 times the opposite of a number, which would be a negative, I'll put this in parentheses because we're multiplying it by it, a -n, right? 6 times the opposite of a number. And this we could kind of write a little bit clearer by saying -10 plus 6. Well, actually not even plus 6. We're going to go 6 times a -n is going to be a -6n. So this is just going to be -10 minus 6n. All right. Do you see that? Okay. Very good. So that is kind of how we work these. Hopefully that makes sense to you. Take it slow. Don't try to race through these. If you do, you'll probably get them wrong. And what I'd like you to do is in the textbook and take a piece of pencil and paper and write this down right now, because tonight for homework, and actually probably for the rest of this week, until you know these, I should really say, until you can do them perfectly, I want you to study for homework these expressions on Lesson 30, page 125. So Lesson 30, page 125. That'll be the homework assignment until we get these memorized. So what I want you to do is, and that's basically going to give you just a great big list, just like what we have here. And I actually just want you to go through and, cover up the answer on one side and read the expression and then think about it and try to verbally translate that expression into algebra, and then check your answer and make sure that you did it right. So, just study that page. Make sure you can get these down, because like I said earlier, we will be using these in story problems, and it's very important that we can translate these pretty quickly and accurately so that the story problems themselves will be accurate. All right? Very good. So last thing that we're going to talk about today, and this is primarily a review, we're going to talk about decimal parts of a number. And it's very similar to what we've already learned. There really shouldn't be anything too surprising here. If I give you something that says 0.32 of, let's see here, what number is 24.32? This is very similar to our fraction problems. There's really nothing different here. The only difference really is that we're dealing with decimals instead of fractions and whole numbers. So the numbers look a little bit different, but the process is totally the same. So remember, when we have these kinds of problems, we recognize that of always means multiply. We recognize that is always equals, and we have what number. We've been interpreting that as WN, right? So this same process follows here. So here we have 0.32 of what number, which means multiplied by what number, equals is 24.32. So that is the algebraic translation of this English expression. And now we just need to solve this. And you can solve this in a number of ways. You could start by eliminating the decimals, like you've learned before. So you would multiply both sides of this equation by 100. Or if you didn't mind working with decimals, you could leave the decimals and just divide it out. So in this case, we'll leave the decimals, and we get divided by 0.32. Let's get that WN by itself. So we divide this side by 0.32, and we end up with WN equals, and now we have to do that division over here, 24.32 divided by 0.32. This decimal we have to move over. We move it over. We get the decimal here, right? And now we have 32 can go into 2,432, right? And we'd have to work that out. So what is that? Maybe if we go a 7, 7 and 14, 22. That looks good. That'd be a 9 and 19, 192. And I think if we go a 6 here, is a 12, is right on. All right, so it's 76. So the number is 76. So 0.32 of 76 is 24.32. All right, so again, the process is exactly the same. We're just dealing with decimals here instead of fractions or whole numbers. All right, very good. So I think we will stop there. Good luck on the seat work today. And remember to study those expressions, those translations for homework until you can say them in your sleep. All right? Very good. So we will see you tomorrow.